Lecture 5.4 of the integumentary system is going to be a bit of an overview. I'm not going to go into great detail about all of these appendages. I would recommend that you come back and look at the slides for some of the more detailed information, but we're really going to focus on just some of the highlights of these appendages, so that's why you'll see me skip around a bit. Those appendages include hair, nails, and then various types of glands, sebaceous, which are oil glands, and sweat glands or sudoriferous glands. All of these accessory structures derive themselves from the epidermis or epidermal cells, so in that superficial layer, but they are actually located down in the dermis. So you have epidermal cells that kind of make their way and live their life, so to speak, in the dermis. And the first of those that we're going to talk about is hair. And so you can see pictured here on the slide a variety pack of the way in which hair comes to us, the different colors and styles and textures of hair throughout our lives. So let's take a little overview of hair. First of all, we are hairy creatures. We have hair on almost all parts of our bodies except what you see listed there on the slide. So very select areas that are hairless, even if it's not noticeable hair. You can see that there are multiple functions of hair. Protection and insulation is definitely one of them. Insects, that's one of the main reasons we have hair, is to notice when we have little bugs crawling all over us, which is just gross to think about, but it is very helpful to us. And they do serve as sensory receptors because they have sensory receptor nerve endings and nerve fibers that are located within and near them. And so that provides us with information. The hair follicle is what's located deep in the dermis, and that's basically what is going to be rooted in the dermis. It's going to have the sensory nerve plexus that's going to be located there. That's called the hair root plexus. You can see here. And you're also going to have what's called the erector pili muscle that's going to attach to that hair follicle. And basically, that's a smooth muscle that acts involuntarily, and it causes goosebumps. So it pulls that hair and makes it stand on end. So we see this happen with our autonomic nervous system, kind of controlling the hair on our body, usually in response to some type of fear or some type of hormonal surge. And obviously we notice this in animals too, that they have this reaction with their nervous systems. I know my cat does it when she freaks out, and other animals do as well. Here are the two primary regions of the hair. So big difference to note, the hair shaft, that's what you see when you are looking at the hair that's visible, whether it is there or on any other part of your body. And then the hair the hair root is the part that is actually anchored into the skin. And so you can see the difference between those two, as well as some accessory structures. So we'll talk about these oil glands in a little while, as well as the erector pili muscle that causes those hairs to stand on end. The three main areas of the hair that we would like you to be aware of, and that's this hair structure portion, are the medulla, the cortex, and the cuticle. And so we'll look at a couple different views. Currently, we're looking at a transverse or cross-section view, so that's that hamburger bun perspective. And so we can see here, the medulla would be that central portion of the hair, and that's got what's called soft keratin in it. So that's a little bit flexible. You have next around that is the cortex, and that's going to have the harder keratin, again, that same protein that we have in our skin. And that's going to give hair its stiffness so that it's not completely, malleable. And then surrounding that here, you have what's called the hair cuticle. It's a very thin layer, but it is tough, and it also contains hard keratin. So an extra buffer layer, if you will, to create essentially the structure that is our hair. So our hair has flexibility, right? I can wrap it up in this bun, but it is also tough, right? I can't completely smush a piece of hair just like I could like a piece of cheese or something in my hand. There are some structures to the follicle, but I'm not going to require you to know them, but feel free to take a look at them at your leisure. Here's an actual microscopic view. So we can see our little hair papilla where we're growing from. You can see your whole follicle. You can see middle portion. There's your medulla. Cortex would be around that. Cuticle would be located here. Here is that root of the hair that's coming up. And then there is the shaft once we have breached the plane, if you will, or breached the skin. All right, and there's those three layers, but looked at from a sagittal cut. So we're looking at it from a side view, essentially. And so there is, again, that medulla. So there's that soft portion in the center, that soft keratin. There is that hard keratin layer, right, the cortex on either side, and then that very thin layer, the cuticle, again, hard keratin wrapping around, creating the individual hairs. Again, these layers of the follicle, I'm not going to have you be too concerned about. The only thing in terms of hair production that we would like you to be aware of is basically that base of the hair bulb, so the base of the hair follicle, is where you have what's called the hair matrix. Anytime you hear the word matrix, it means division, stuff's happening, dividing. And basically you have those epithelial cells and they form that matrix, and that's what produces our hair. And hair gets pushed up and out. So as the follicle essentially is dying out, right? It's been there for so long, depending on which hairs they are and where they're located on the body, that'll get pushed up and out and eventually shed, while a new matrix, a new follicle is being built underneath or deep to that. And here's that growth cycle for you. In terms of growth processes, that root is going to be attached to that matrix. It's going to be inside of that follicle. Eventually, that follicle will stop dividing, and that's going to be controlled hormonally as well as genetically. And so different hairs on different parts of your body are going to have different life cycles. So the hair on your head is going to have a different kind of span, follicle span, than your eyebrows, then your facial hair, then your armpit hair, then your pubic hair. All of those are going to be on different cycles. And each individual follicle in that area is on its own cycle. In other words, every single follicle on your scalp is not starting day one, grow a new hair. If that was the case, we would shed our hair like a molting, where we would shed all of our hair at the same time and new follicles would produce. I mean, that'd be kind of interesting, but that's not how it works. And again, that's probably a good thing because we are utilizing that hair, or at least evolutionarily, we're using that hair as protection. And you don't want to be completely bald or hairless everywhere if you're using that as part of your protective nature, okay? So once that follicle becomes inactive, obviously growth stops, and we call that hair a club hair. So basically a hair that's going to be shed. A new follicle is produced in the dermis and is starting to produce a new hair, and so that club hair essentially gets pushed up and out and sheds away, okay? A couple of the other things, I know I mentioned hormones and I mentioned genetics, but nutrition really impacts your hair, your nails, etc. I feel like there's a lot of talk about, taking things or putting extra supplements and things like that in foods or beverages. And some of those are things that help to increase hair growth and nail growth and strength. And so your nutrition, how healthily you eat, also impacts that as well, okay? There's your reminder that we don't molt, all right? So they alternate between what we call active and regressive phases. And then there's just some numbers for you. It says 90 scalp hairs per day. I feel like when I brush my hair at night, there's way more than 90, but maybe that's just me. There are two categories of hair. You have very soft hairs that are located on most of your body surface. So those really thin ones that don't necessarily stand out unless you're looking closely. That's called vellus hair. You see that a lot on babies as well. And then you have terminal hairs. Terminal hairs are the highly and heavily pigmented hairs, the hairs that are noticeable. So on your head, on your eyelashes, on your eyebrows, and genital area or pubic area once you've hit puberty. And then obviously we have various types of hair colors. And that's because they are produced by, the hair color pigments are produced by the melanocytes located in the hair matrix. And so the different types of melanin that we have and are produced in the different amounts are going to result in the different color hairs we have. So the melanin pigments lead us to the blondes, the brown, and the black hair, depending on, what type of, if we've got the red-yellow mix or we've got the brown-black mix of melanin pigments. Trichosiderin you have is for red hair. So that's a different pigment that is located in our gingers as well. And then as we get older, sadly, or we get super stressed, as you have seen multiple times with me in the great angles of these Google Meets, our melanin levels start to decrease as we get older, or various hormonal surges can cause those to decrease as well. And you result in white or gray. So you don't produce the pigment, and so you just have the white or the gray hairs that show up. In terms of our glands, these are also accessory organs to the skin. There are two primary types. You have sebaceous, which are oil glands, and you have sweat. And they come in two main types called epicrine and eccrine. Sebaceous glands basically secrete sebum. Sebum is the fancy word for oil. And the majority of them do secrete that sebum into hair follicles, and that serves a couple of purposes. There are components located in the sebum that act as inhibitors of bacterial growth, as well as a lubricant for our hair follicles, as well as for our skin. So there are those two types. Here's the simple branched alveolar gland, aka a typical sebaceous gland, and that's what you see pictured here, right? It is attached to a hair follicle, and it's going to dump or release its sebum into that hair follicle, and it's going to lubricate the hair shaft. That's why when you don't wash your hair for a long time, it tends to get greasy and oily. Here is that transverse cut. So you were looking at a top-down view of our sebaceous gland linked to the hair follicle itself. Okay, so there's where that sebum is discharged into the hair follicle for lubrication. You also have sebaceous follicles, and sebaceous follicles are not associated with hair follicles, as you can see. And basically, they release sebum directly onto the skin surface. And you can see that's located in a few areas. Sorry, my mouse just made that appear. We have them on our face. We know that, right? When these follicles get plugged up with stuff, backed up, or filled up with too much sebum because hormones are causing them to release too much sebum, that's when bacteria can get caught in it. And so they start to change color and they get pussy and they may look red. And that's what we call acne. Because those follicles tend to get plugged up in those particular areas. You also have two types of sweat glands, and those are called apocrine and eccrine. Apocrine glands are interesting type of sweat gland. They are found in our axillary region, so our armpits. They're found around our nipples, and they're found in the pubic region or your genital region. These are sweat glands that do secrete into hair follicles. And release their sweat, if you will, into those areas. And their sweat is not the sweat you think of when you think about exercising. Apocrine sweat is sticky and it's cloudy, and basically it's got some yummy food for bacteria in it. So that's why when you, have been out all day and it's been hot and you've been sweating, especially in your armpits, and you lift up your arm and you're like, whoa, that's not how I smelled this morning. The reason being is that the bacteria that normally lives on your skin basically had a buffet that came out of those particular areas. And so that's why those particular areas where apocrine glands are located on the body tend to have odors, especially when people don't clean them immediately. And it's not from the person. It's from the bacteria that is sitting on the person that is consuming and breaking down the proteins and other compounds that are located in the apocrine sweat. And you can see an example here. There's an apocrine sweat gland squeezing that out into the hair follicle and onto the skin. So again, in those armpit areas and those pubic regions. Sweat glands that we think of when we think of sweat glands, like, oh, I'm sweating, it's so hot. Those are called eccrine or merocrine sweat glands. And these are basically very tubular, coiled glands that secrete sweat onto our skin. And this is the sweat we think about when we think about sweat. It's practically water, all right? It's about 99% water with a smorgasbord of salt and some ions and even a little bit of urea, which is the main component of urine. So all of those things are located in your sweat. And basically, they're located almost on every single body surface that we have. And that's because these are the glands primarily used for body temperature regulation or thermoregulation, which we talked about in Chapter 1. And here are three of the main functions for that. Again, that secretion of water and that thermoregulation are key functions, as well as providing protection from environmental hazards. So in other words, there are some components that are located in that sweat that could act as protective assistance to our body. And we can take a look there. There was that apocrine sweat gland here. And where is my eccrine gland? Right here's my sweat pore. And so there would be my eccrine gland as well. A couple of modified sweat glands that we have, which is so weird to think about when you think what they actually release. But they are modified sweat glands. So the first are our mammary glands. So for women, our mammary glands are modified sweat glands, and they produce a modified sweat called milk that babies drink. And again, that's hormonally controlled. And then you have what are called ceruminous glands, which produce a modified sweat called cerumen, which is our earwax. And again, both of these structures have functional capabilities. Milk obviously is providing nutrients and antibodies to our offspring. Cerumen or earwax is catching foreign particles that make their way into the ear. Right? We won't talk too much about control because we'll do that when we get to the nervous system, but you can certainly take a look at what those control mechanisms are. Last but not least, in terms of our accessory organs, are our nails. Our nails are our scales. Basically, they protect the surface of our fingers and our toes. Again, dead cells that are packed with that protein keratin like we saw in our skin. And there's a variety of disorders that can happen when you don't have good nutrition or good skin health that can do damage to your nails. So there's various parts of the nail, your nail bed and your nail body. You have a couple of areas like your cuticle, as well as your free edge where the growing is occurring. Obviously, we're growing out from the eponychium, which would be the cuticle here on our sagittal view or longitudinal section here. And you can see a couple of those areas listed. I'm not going to ask you a lot of questions on the nail, just food for your own thought to take a look at that should you be interested in that. Okay. Last part of this unit just gives an overview of how your integument repairs itself if it gets injured. So, obviously we've all had a cut or scraped our knee at some point, so we kind of know how this works, but here's your general flow, and we'll go through the 4 phases of this in a minute. You bleed, you have some edema or swelling, and usually it's kind of painful, right? That injury triggers what we refer to as the inflammatory response, and we'll talk about that in a minute. Once that inflammatory response does its job, you end up with what's called a scab, which is basically a blood clot that is dried up. And that essentially creates a protective covering to protect the area. White blood cells called macrophages come in, little Pac-Men, and they gobble up all of the junk and bacteria and things that have made their way in there or that are debris that needs to be cleaned up. And then you have new healthy cells, either connective tissue cells, fibroblasts, or epidermal cells, endothelial cells that are going to undergo mitosis and produce granulation tissue or repair tissue as well. So that first phase is called the inflammatory. That means we bleed, we've got some redness, blood vessels are sending high levels of oxygen and nutrients to the area, as well as white blood cells. And that is going to create that redness, that swelling, that pain. Next, you have what's called the migration phase. And basically, you can see you have migrating epithelial cells. So cells that are going to make their way into the area along with macrophages and fibroblasts. So along with tissue repairing cells or tissue making cells and white blood cells that are going to be present. And they are basically going to clean up the area, get rid of the debris, and then they are going to increase blood flow to the area so we can get more nutrients in, so we can essentially build more cells to repair the tissue, as well as get more platelets present so that we can essentially clot the blood in that area, cause that stickiness to happen, so we can plug that off and get to work in the proliferation phase. Proliferation, usually anywhere, a few days to a week after. Basically, you have a scab on the surface, which you can see up here is that dry blood clot. And you have these fibroblasts, these collagen and connective tissue producing cells that are going to essentially create like a stitching of the skin and make these new cells. The majority of the white blood cells have cleaned up the debris in that area, so that should be pretty much done. And then the clot of the blood for the blood vessels is usually, for the most part, getting broken down, if not completely broken down at that phase. And lastly, you typically will end up with some type of scar tissue. And this is, a few weeks down the road. Healing of the epidermis has taken place. You might have a little bit of a depression in that spot. But the scar tissue is important to note because scar tissue is not the same cellular makeup as the tissue that was there before. And that means that if a nerve ending was there or a receptor, you won't have that there anymore. So you might have an area of your skin that no longer has a certain type of sensory reception because those cells were not repaired and they were damaged in whatever that injury or wound was. Something else that might happen is you might have besides that scar tissue, you might have something called a keloid, and there's an image down there. Essentially an overgrowth of repair in a particular area, and usually they're raised. They're not harmful, they just look, noticeable, that's all. But that could be a reaction that your particular genetics and skin have. You can read through the whole list of things that happens as you get older. I don't like to talk about them too much because I'm getting older, and so a lot of these things are happening. But the bottom line is things tend to break down or thin out or lose their pigment or lose their protein, lose their elasticity. So basically, as you get older, the skin starts to sag and wrinkle, get thinner, so you're always cold, lose your pigmentation, so you may get paler or your hair may get lighter. Those are all some of the things that might happen. Hair gets thinner, nails get a little more brittle as you get older.